Hello, Leiden geometry students. In this assignment, we are going to talk about simplifying square roots. First off, square roots have shown up when we do the Pythagorean Theorem problems. At the end of the problems, we always end up taking a square root to cancel out something squared. So, what is a square root? Well, we're going to talk about square roots, and we're going to use these two words, a radical and a square root. They basically mean the same thing, at least for this class. A square root is a type of radical. But if you hear someone say radical or see the word radical, for the time being, it means the same thing as square root. So what is a square root? A square root is a way of asking what number times itself gets this value. In other words, the square root of 25 means what number times itself is 25. And the answer is 5. Why? Because 5 times 5 is 25. Square root is a way of asking what number times itself gives us this. Before we start, there's a common mistake people make is after they take the square root of 25 and turn it into 5, they keep the square root there. And that should go away after you take the square root. Once you've figured out what number times itself you use to get your square root, the square root symbol should disappear from the problem. Okay, so the square roots you should already know are the easy ones, numbers 1 through 12 squared. Square root of 1 means what number times itself is 1? It's 1. What number times itself is 4? That's 2. What number times itself is 9? 3. What's the square root of 16? Or what number times itself is 16? 4. The square root of 25 is 5. The square root of 36 is 6. And all these other numbers are ones you learned in your multiplication tables in grade school. These numbers that we can take the square root of fairly easily, and it comes out to something nice, not a weird decimal, we call these numbers perfect squares. And you will have to know these numbers. Do you have to memorize them? No, but it's easy. It can be easy to do this if you just remember how we got them. We just took numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and squared them, multiplied them by itself to get them. So you should be able to create this list if you need to. All right, so what do we do if we have a problem that looks like this? What's the square root of 16? Well, if it's just asking you what number times itself is 16, if it's one you know, you can just write the answer. What number times itself is 16? Well, that's going to be 4. So if it turns out to be a square root of a perfect square, you can just write the answer. Those are the easy problems, but we do have some harder problems we're going to have to deal with. And that's when we have a problem like this, the square root of 20. What number times itself is 20? And the answer is, it's nothing nice. No number times itself, no integer times itself is going to be 20. So what we have to do is deal with what do we do when it doesn't turn into a nice number? I know somebody deep down is thinking, what about 10 and 10? 10 plus 10 is 20, but a number times itself, to get 20, it's not going to work out to a nice number. 4 times 4 is 16, and 5 times 5 is 25, so it's somewhere between 4 and 5, and it will be a decimal. You have two options on how to deal with this kind of problem. We're going to talk about one, the approximate answer. That's where you just bust out a calculator and get a decimal. The second option is going to be to get the exact number. That's where our work's going to be here, is reducing a square root. And you're going to have to be able to do both of those. So option one, the easy one, if we're looking for an approximate answer, that's a decimal because it's going to be rounded off, we just type it in the calculator. You can usually find the square root button somewhere on the left-hand side of the calculator. Find that button and take the square root of your number, and the calculator will just turn it into the decimal for you. It's usually above a button, so you might have to hit a shift or control button first to get it. But we get this decimal, 4.472, blah, 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 blah. And you'll have to follow the directions on whatever assignment you're doing to figure out how many decimal points to round it to. This isn't the best answer while it is the easiest, but it's not the best because we'll have to at some point round it off. This number will go on forever, like pi. It'll go on forever and never repeat, so it must be rounded, so it's never really that accurate. That's why we call it an approximate answer. The decimal answer is an approximate answer. It means it's been rounded. So what if we can't give an approximate answer? What if we have to get an exact answer? Okay, simplifying a square root is a lot like working with a fraction. There's a lot of different ways you can write the same thing. For example, All these fractions on the bottom of the screen, they're all the same thing. They're all 1/2. 1 out of 2, or 2 out of 4, or 10 out of 20, or 6,000 out of 12,000. They all have the same value. They're just different ways to write it. Square roots kind of work the same way. There's a whole bunch of different ways we could write the square root of 20. And all these values up here mean the same thing. They all give the same value. But one of them is going to be the best answer. Just like for the bottom, 1/2 is the best answer. It's the simplest fraction we can give that has this value. On the top one, 2 square root of 5 is the simplest answer we can use, and it gives the simplest version of the answer. But now, how do we get that? So here's the simplest way that you may have already learned on how to get an exact answer for a problem. We want to take the square root of 20. It doesn't come out to a nice number, and we don't want a decimal, so what we're going to do is break it down. Remember, a square root is when we have a number times itself to get this value. So we're going to take this 20 and break it down into what numbers are being multiplied to get 20, what's called the prime factorization. So you take the 20 and you think of any two numbers you can that multiply together to give me 20, any two integers. Most of us would say 2 times 10. You might say 4 times 5. That would work just fine as well, because once you've done this, you break down these numbers again if you can. 2 can only be broken down as 2 times 1. That doesn't help. So if it can't come up with unique numbers, different numbers to get here, then we stop. But 10, we can break down 10. That's 5 times 2. If you started off by making 20 as 4 times 5, you'll end up with the same 3 numbers at the bottom of your factor tree anyway. Once we have our factor tree completed, these are all numbers that can't be broken down any further. We're looking for pairs of numbers. Here, we have a pair of 2's. Anytime you can find 2 of the same number, they don't belong in the square root anymore. They just become a normal number. So our answer is going to start with 2. But this 5, it doesn't have another 5 with it. It doesn't have any partners. That means it's going to stay in the square root. So 2 times the square root of 5 is our final answer. This is the simplified version of the square root of 20. So take a moment and try to break down the square root of 60. Start by making a factor tree, what numbers multiply to 60, and then break those numbers up until you can't break them up any further, and then look for pairs. Anytime you find 2 of the same number, they come out of the square, it comes out of the square root. Okay, for 60, most of us would start with this, saying that this is 6 times 10. We can break up the 6, that's 2 times 3. 2 and 3 don't break down any further, they're prime, so we come over to the 10. 10 can be broken down, that's 2 times 5. But now all these numbers can't be broken down any further. These are the prime numbers. So we find any of the numbers that we can find a pair of. Here, once again, we get a pair of 2's. So the first thing is those 2 become one normal 2 out front. Everything else doesn't have a partner, it's going to stay under the square root, and we're going to have to multiply them back together. Here we're going to have the square root of 3 and 5, and we multiply them back together to get the square root of 15. And this is our final answer, 2 times the square root of 15. Try the same thing for the problem on the right, 75. All right, first thing we do is break it down, and it breaks down to 25 times 3, and the 25 can be broken down to 5 times 5. And this is it, 5, 5, and 3, these are all prime, they won't break down any further, so we start looking for partners. We got a pair of 5's, that becomes a normal 5. 3 doesn't have any friends, so he goes back under the square root alone, and that's our answer, 5 square root of 3. There is another way to do square roots that is a little bit faster, but requires that you remember something and are somewhat good at division. You don't have to do the problems this way. However, if you have a really big number, this is going to be the faster way to do it. What we need in order to do it this way is we need to remember that list of numbers so we can take the square root of 1, 4, 9. Remember, these are all the numbers that are 1 through 12 times themselves, 7 times 7 to get 49, and 11 times 11 to get 121. And what we need is the biggest number on this list we can divide 20 by and not get a decimal. And that's where the trick comes in about being good at division. But if you look here, if you notice, 4 is the biggest number on this list I can divide 20 by and not get a decimal. We do 20 divided by 4, and we're going to get 5. So I'm going to rewrite this square root of 20 as the square root of 4 times the square root of 5. 4 times 5 would give us 20. And we know the square root of 4. The square root of 4 is just 2. The final answer is 2 square root 5. That's it. The problem is done. The nice thing about doing it this way is it is always 2 steps. However, if you do the factor tree, depending on how big the number is and how many factors it has, it could have a lot of steps, but this is always 2 steps. So we're going to try the same two problems this way. So if we start with the 60, we want the biggest number on our list. We can divide from 60. 60 divided by 4, once again, is the biggest number on our list. It'll work. So I'm going to rewrite this as square root of 4 times, and 60 divided by 4 is 15. The reason we like this is we know the square root of 4. It's 2. We end up with 2 square root 15, and that's our final answer. If we do the other problem here, square root of 75, the biggest number on our list that we can divide 75 by is 25. All the other numbers give us a decimal. So this is square root of 25 times square root of 3, because 25 times 3 is 75. And we did this because we know the square root of 25. The square root of 25 is just 5. Whoops. Whoops, my mistake. It was supposed to be a 5. I had a 3 there. But 5 root 3, that is our final answer for this problem. Okay, so the square roots, this is all algebra stuff. Where does this come in handy? Well, sometimes we might have a Pythagorean theorem problem, and you'll be asked to give an exact answer for the problem. For example, in this one, we want to find the length of the hypotenuse. It says to give both an exact and an approximate answer. So we're going to start with the Pythagorean theorem. We got 10 squared plus 5 squared is x squared. Now, in this case, it's okay to give the approximate answer first, so go ahead and finish this one and give the decimal answer rounded to 1 decimal place. 10 squared plus 5 squared is 125, and then we're simply going to take the square root. The approximate answer, just type that into a calculator, we're going to get 11.2. But we may have to give the exact answer as well. For this case, we're going to have to break down square root of 125. If you do that, 125 becomes 25 times 5, which becomes another pair of 5s. Here we take 2 5s and make them a normal number. And this extra 5 stays under the square root. And there's our final answer, 5 root 5, or 11.2, depending on whether we want the approximate or exact answer.